You're good.
I talked to you this afternoon about planets, and we had a special session on Venus. But what do we look at when we look outside of our own solar system? These are what are referred to as deep sky objects. And I want to just very briefly talk about what do we see and why do we see them. I will show you a few examples, essentially based on the list from Charles Messier, who I'll tell you about in very, very briefly. But I'm not going to go into too much detail because I'm being followed by 3 sessions with folks showing you their favorite deep sky objects, and they will probably be telling you in detail more about them than I will. But I do want to nevertheless set the folks up that maybe don't have too much experience with things like galaxies and star clusters, so to give you an idea of what the range is that we're talking about. There we go. So what do we see and why? Well, it depends where you're looking. There are 2 places you can look for these deep sky objects. One is inside our galaxy and the other is outside. If we look inside, then we'll be looking at things that are related to stars or to nebulosity, clouds, for example, from which stars might have been born, or other clouds which might be formed when stars die. And if we're looking outside of our galaxy, then we're probably looking at other galaxies at great distances, somewhere in the order of maybe tens of millions of light years away. For example, the closest galaxy to us is the Andromeda Galaxy, which if you're young enough, you might be able to see with the naked eye. I can't. Just to put galaxies into perspective, this is an image of our own galaxy. The little red dot that you see to the right of the center there, that's meant to represent our home in this galaxy. That's supposed to be where our sun is. It's not that big, of course. And our galaxy is about 100,000 light years across. I say about because there have been some recalculations, some new measurements, and we're thinking that it might actually be even bigger than that. But it's of the order of 100,000 light years across. So when we're looking inside our galaxy, we're not looking at things which are tens of millions of light years away. We're looking at things which are closer. So what kind of thing would you look at inside of our galaxy? Well, a lot of it revolves around star clusters. The Milky Way is a disk with dust. I've mentioned this already. You get a lot of dust. That's the dark stuff here between the bright arms of the galaxy. And that dust prevents us from looking too far. So we're really looking at stars in our own neighborhood. And we're looking at open clusters of stars. They may be associated with the nebulosity from which they were born. And that, by the way, is the kind of circumstance where our own star was born. It was born as part of an open cluster, sitting somewhere and forming somewhere within a gas-rich and probably dust-rich nebulosity. There are other clusters which are much more close-packed. I'll mention those a little bit more when I actually get to them. Those are called globular clusters. And then of the nebulosities, there are these vast clouds, which are the nurseries from which stars are born. But there are also the signs of death of stars, what are called planetary nebulae, and supernovae. I don't have any images of supernovae for you. If you look outside of our galaxy, then as I say, we're looking at other galaxies. And again, because the Milky Way is a disk, if we look with a line of sight within the disk, then we're probably going to only see stuff that's actually in our galaxy. We'd have to be looking outside of the Milky Way. And when you see the sky at night, if you can see the Milky Way up in the sky above you, then you can actually see where the plane of the galaxy is, and then you know how to point your telescope outside of the plane. And that's when we will be looking at other galaxies, and they could be of all kinds of shapes and sizes. And that will be determined in part by their real size, their real history, have they interfered with other galaxies and become misshapen? How far away are they? And their orientation to our line of sight. We may be seeing them face on, we may be seeing them edge on. Well, Charles Messier put together this list of what many amateur astronomers consider to be some of the biggest and brightest deep sky objects in the sky, at least in the northern sky. Charles Messier lived from 1730 to 1817, and he worked in Paris. Now you might think, why would you work in Paris? It's a big city. Well, at the time, at the beginning of at the end of the 18th and beginning of the 19th centuries, there was in fact an opportunity to observe the dark sky, even in Paris. He was good, But what he was really looking for, he was looking for comets. And he kept being distracted by these fuzzy objects that he could see through his, what we would now consider to be an optically poor and optically small telescope. He could see things which he couldn't quite make out what they were. Were they comets? Well, when they didn't move after several nights, he knew that they weren't. So he tried mapping them out so that he could actually prevent being fooled by these things when he was sweeping back and forth through the sky looking for comets.
Yes, Simon, we have a question for you.
Okay.
From Dennis. Since we can't see our own galaxy, how much agreement is there on what it would actually look like from afar?
Oh, pretty good, because in fact, although we can't see it as amateur astronomers, the professionals can. We're looking in white light, or we're looking in perhaps H alpha light, this kind of thing. But the professionals are using radio waves. And by imaging in radio, they can see right the way through the dust, and they can see right the way through to the other side of the galaxy. Now, admittedly, they're getting their results are not images, their results are numbers, which they then put into a model and crunch. Is the model giving a unique solution? This is why there are different schools of thought about exactly how many arms there are in the galaxy, exactly how big it is. But yes, we've got a pretty good idea of what it would look like from outside of the galaxy. So as I say, Charles Messier was pretty good. He actually did get some very nice objects. There are others which he didn't actually see, even right next to the ones he did. So he didn't always highlight the best ones for us. So what I want to show you now is a small selection from downtown Ottawa. The kind of thing that I've actually been seeing myself. These are essentially my own images from my backyard in Ottawa, taken with various telescopes, various cameras. I won't get into the details of that. But what I will do is highlight mostly the Messier objects among these. So let's start by looking inside our galaxy. And remember, even with a radio telescope, you can only see up to about 100,000 light years away. That's the maximum scale of our galaxy. We'd be looking much, much closer than that. So here's a typical example of a large open cluster of stars, M52 in Messier's catalog. I don't see any nebulosity here associated with these stars. So these stars were born from a dust and gas cloud. This is probably the kind of circumstance, as I say, that our own star and solar system was born in. These stars will then eventually disperse through time. Obviously, they've consumed or blown away the relic dust and gas from the cloud from which they were born. I rather like this image. M35, M35 is the large cluster in the upper left. And it's one of Messier's clusters. But down in the lower right is a different cluster. He didn't actually list this one at all. And if you, just for the sake of argument, I don't actually know how big that lower right cluster is, but imagine that it was around about the same order of magnitude of size of M35. If it's looking small like that, then it's further away. And what I like about this image is it gives you this 3D perception of space, with something being closer and something being further away. Here's an example of a star cluster. This is M16, but here you can actually see the nebulosity, the cloud of dust and gas from which these stars were born. And although this is a sort of a broad view, a broad overview, a picture of this, if you go into, there we go, get this. If you go in here, that rather opaque looking dust in there looks like an eagle trying to take off, and that's where this cluster gets its name from. But the thing is that dust there, that contains the famous Pillars of Creation NASA Hubble photograph, which became iconic for showing how stars are actually born in nebulosities associated with star clusters. Here's a beautiful star cluster associated with a nebulosity. It looks like North America, which is why it's called the North American Nebula. It's sort of North America on its side with Canada in the north to the left and the Gulf of Mexico down to the right. But where's the nebulosity? I see lots of stars, Well, to get to the nebulosity, I had to change my system completely, and I put what Jim has told us is an H-alpha filter onto my telescope to take exactly the same image. And here I've highlighted the nebulosity, the gas and dust, if you will, from which the stars may have been born, but the stars are less resolved simply because of the setup of the system. And here's another example. This is not one of Messier's examples, nor was the previous one. This is called the Wizard. But again, it's a beautiful, beautiful, huge, extensive gas cloud in which stars are born. And the dark stuff in here, for example, that's opaque dust. And the opaque dust is actually, in this particular instance, in front of the brighter gas behind. So again, this three-dimensional effect in the image. Let's move on. Sometimes you get a bubble, sometimes you get a nebula, and it's not necessarily related to birth of stars. In this case, it's a bubble that's been blown up by a star somewhere in the middle of the bubble, which was radiating photons and presumably it's solar wind so strongly within the nebulosity that it literally blew a bubble. And this, of course, is known as the bubble nebula. And no, this was not one of Messier's either. Globular clusters are a very different kettle of fish. Instead of the stars being broadly scattered and maybe a few tens of stars to 100, in this particular case, this is M13, the biggest and brightest globular cluster of the Northern Hemisphere. And it contains up to 1 million stars. Those stars in the core are so close together that if a planet was going around any one of those stars, the suns, in the plural, would never set. There would never be night. The stars are probably so close to each other that they're about as close to each other as the distance from our sun out to about Pluto. That's a pretty close packing of stars there. One of the remarkable things about these is that the stars are not going around in an orbit. They're buzzing around like bees on random orbits. I'm not even going to try and explain to you why. I know why, but it's complicated and would take too long. The other thing is these objects, these globular clusters, tend to hover around the edges, the outer edge of our galaxy. And they are among the oldest features, not only of our galaxy, but even of the universe. They're about 13.5 billion years old, which is approximately the age of the universe itself. Sometimes a star will have more or less had enough towards the end of its life, and it will go through a process. It's not a supernova, it's not an explosion, but of blowing off the outer layers, which then form bubbles around the star. And this is a classic. This is M27 from Messier's list. You can actually see that this bubble is very complicated. It's got the main bubble is here, and then it's got these wings coming off as though there are a series of bubbles nested into each other, as though the planet actually, the star blew its outer layers off in several phases, in several pops. And this is probably one of the largest, I think it is the largest planetary nebula that we can see from Earth. And it is one of the favorites of amateur astronomers to observe and image. This is a beauty. This is the equivalent of what we just saw. It's smaller because it's actually further away. This is called the Engagement Ring Planetary Nebula. And the reason is that by pure coincidence, there's the ring of material popped off by from the outer layers of the star. And it just so happens that in line of sight, I believe in front, but maybe it's behind, is a star which looks like it's sitting like a diamond in an engagement ring. This is a beauty. This one here, the Oyster Nebula, this is not a Messier one either, but you can actually still see the white dwarf star in the middle from which the outer layers were blown off. And you can see the delicate blue color, bluey green color of the nebula, which is characteristic. These were called planetary nebulae because in the early 19th and late 18th centuries, when they were first observed through telescopes, people couldn't see any kind of structure, but they could see that they weren't just points of light, and they had color to them, and they thought they might actually be planetary type objects. Or a star can actually blow. And although I can't show you the supernova itself, this is a supernova remnant. This is what's left over. This is M1, the very first object in Messier's list. And the reason this is absolutely important to us as human beings is that the supernova that actually gave rise to this was observed, and it was observed and recorded by the Chinese in the 11th century AD. And they could actually see this, this star as it went supernova. They could see it during the daylight for up to 3 months. This is what's left. Here's another example. This is called the Crescent Nebula. I don't know where the star would be for this. It's a supernova remnant again. And you can see lots of gas, which has been blown off, but in almost every direction, and lots of filaments. Here's another supernova remnant. This is one part of an absolute classic in the constellation of Pegasus. This one's in color for once. And this is part of the veil. And on the other side of the veil is this. Again, another part of the veil. The star itself was probably down to the lower right. Well, what about looking outside of our galaxy? What would we see there? And as I say, we could be looking out towards distances of tens of millions of light years. Well, here is the iconic, classical M51. I rather like this picture. I took this picture about 2 weeks ago from my backyard here in downtown Ottawa. It shows lots of beautiful detail. It's a classical spiral galaxy. You can see bright areas in the arms, which is where stars are probably forming in that galaxy. The core of the galaxy, the stars are so densely packed there that it's just overexposed and bright. And in some of the arms, you can actually see dark trails of opaque dust. And the object to the top, above the main galaxy, that's a second order galaxy which came in, swung by, and actually dragged some of the main galaxy's stars off along on a bridge. This is a close-up on the same thing, which I took with a very different camera. I think you can clearly see the dark lanes in some of the arms, including in the arm that links the main galaxy out to the subsidiary galaxy. This is a very different kind of spiral galaxy. This is M63. When we looked at M51, it was face on. This is sort of oblique. It's an oblique view, and the arms in this galaxy are totally different. In fact, there are so many they're almost difficult to define and count. This is another galaxy, again, in a different perspective. This one here is, the previous one was known as the Sunflower, by the way. This again is a Messier galaxy here, known as the Black Eye. I think you can see why it's called the Black Eye. And you can clearly see here, I think, that this galaxy shows you an inner core, an outer core, which sort of forms the eyelid, an inner disk, and then an outer disk. And although it is a spiral galaxy, we can't actually see any of the spiral arms. They don't actually show in any of the images, even images of a higher quality and higher resolution than this. Here's another spiral face-on galaxy, M94, another one of Messier's. This one's known as the Crocodile's Eye. And I wanted to show you this because you can clearly see that there's a bright inner core. There's a sort of crinkly outer core. And you can just make out some spiral structure in that core. And then there's this very faint but very, very broad outer disk. Here's a large spiral galaxy, again one of Messier's. This is M101. It's a beautiful large spiral object. I really don't have time to tell you much more about this one here. Just wanted to show you an example of two spiral galaxies, M65 and M66 in the constellation of Leo. They are not quite face on. The one on the left is rather distorted. Possible that the one on the right actually swung by it, I don't know, maybe a billion years ago, and did something nasty to it. I just wanted to show you, to finish off here, a couple of galaxies edge on. Here's a beautiful Messier galaxy. This is known as the Sombre Arrow. I think you can see why. It looks like a Mexican hat. And the beautiful thing here is you can clearly see the bulge of the core of the galaxy. You can see the disk reaching out towards the upper right and the lower left. And you can see this dark lane running along the disk. That is a disk, that is a lane of dark opaque dust. The dust that I was suggesting was preventing us from seeing too far in our own galaxy. Here's another classic spiral with edge on with exactly the same kinds of features, so I'll move on from there. And then I took this one myself the other week as well. I just want to show you a close-up on this. The same kinds of features, a very, very bright but small core, an extended disk going up to the top right and down to the lower left. And again, you can see a dark lane of dust. So to finish, I just wanted to show those folks who are not familiar with clusters and galaxies and nebulosities, the kind of thing that we're looking at. Here is the classic. This is our nearest neighbor. This is the Andromeda Galaxy. It looks very much like we think we would look like if we were actually in the Andromeda Galaxy and looking back at us. It's somewhere in the order of 2 million light years away, and it's coming towards us. By the way, in this image here, just to finish, you can actually see several galaxies. M31 is the big one, and you can see one up here, and you can see another one down there. That's M32, and that's M110. And that, I think, takes me to the end. Let me just check. Yes, it does.
All right, thank you, Simon. We have one question in the Q&A from Darcy. I know you have a lot to cover, but why do galaxies have a bar in the center?
Oh.
Is there an intuitive explanation for that?
It's not intuitive. There are all kinds of mathematical models trying to describe what's going on here. It would take a long time to get into, and there are several schools of thought to explain that.